same as that of the Colpis oscillator with the minor difference. So here's the Colpis oscillator. There's a tune circuit. The capacitors are shown C1, C2, and the inductor is attached. This is a tune circuit. Here, Hartley oscillator, the inductors and the capacitor. There's a tune circuit, the inductors and capacitor. Here capacitors and inductor. There's a Colpis oscillator. So, in this oscillator, instead of using tapped capacitors, two inductor L1 and L2 are placed across the common capacitor C. Center of the inductor is tapped, as shown in the figure. Here is a tapped inductors are used in Hartley oscillator. Okay, so this is a transistor. Okay, emitter, common emitter configuration, RE and CE. And here VCC is applied, R1, R2 biasing resistors, and the feedback is through capacitor C1 going to base. Okay, here's a tune circuit, and output is taken at here. So this is the output at here. Okay, this is a Hartley oscillator circuits. So this RF choke, it purposes as like a load. So tank circuit is made up of L1 and L2, and these two inductors at the center it is tapped. The tank circuit is made up of L1, L2 and C. The frequency is given by the formula that F is equals to 1/2 pi under root of C into LT. LT is L1 plus L2 plus 2M. So L1 plus L2 plus 2M. M is the mutual induction between the two coils. Hartley oscillator is there are two types of Hartley oscillator, but we are discussing shunt fed Hartley oscillator. So we are discussing the one out of the two, and the circuit is very simple. When the key is turned on, the capacitor begins to charge. Like this is a supply VCC, and this capacitor begins to charge. Okay, when the capacitor is fully charged, it is charged to L1 and L2. So when fully charged, it is charged to L1 and L2, and setting up the oscillation, and which is given by the formula. This is the formula. Okay, a phase shift of 180 degree is introduced by common emitter transistor, and a further phase of 180 is produced by voltage. There's a tuned circuit. So tuned circuit, transistor gives 180 phase, tuned circuit also gives 180 phase, total becomes 360, and the signal, it is in phase at the base. Okay, so total phase shift is 360 degree, and this is very necessary condition to produce continuous undamped oscillation. So this is the equivalent circuit. Here it is HIE, input impedance. So this is a feedback voltage source, this is a current source, this is a output admittance, and that is in the form of resist. This is tune circuit, and tune circuit feedback to the input side. So this is a current source and resistance. Okay, resistance is 1/HOE. So by using the Thevenin theorem, the current source is converted into the voltage source. This current source converts into voltage source, and then the resistance comes in series with the voltage source, 1/HOE, and here is the V2, the voltage across the between the 2 points. So 3 loops, 1, 2, 3. the loop number 1, we traverse clock. This is loop number 2, loop number 3. So 3 loops, loops 1, loop 2 and loop 3. Okay. So now let's the voltage here between the 2 points. The voltage across this 1 over HOE. This is, I2 is current flowing I2 into 1 over HOE by Ohm's law. And second voltage is in opposition. So that's why the minus sign. Okay, loop number 1. Here traversing clockwise direction. So this is a voltage at here. Voltage at here. Then the second voltage is this one. Then voltage across the inductor. There are 2 current flowing, and the 2 current are in opposite direction, I1 and I3. So that's why there is a negative sign. So V2 is equals to, this is equation 1. V2 substituting here, and we got the equation number 3. Now similarly applying the Kirchhoff law to the loop number 2 and 3. Here the voltage across this, then this is a voltage source, and both are opposite. Both are opposing in nature, so that's why negative sign. Then like here the 2 currents, and 2 currents, they are flowing in same direction, I2 and I3. So that's why I2 plus I3 is here, because I2 and I3 both are flowing through L2 along the same direction, this direction, and I3 along this direction. So that's why there's a plus sign. Okay.